I am Joydeep Samansar. Just to briefly introduce myself, I'm a technology evangelist and enterprise architect. I head the strategy office for analytics and insights unit within TCS. So, just to give you a background, for the last few years, everyone's talking about digital, and there is no doubt that we are in the digital era. And the technologies which has had the biggest impact in the recent past is the emergence of the social and digital technologies. They're disrupting the status quo. They're having a very profound impact on every business as well as individuals and customers. It started with different acronyms: SMAC, SCAM, CAMS. Gartner called it Nexus of Forces. But now I think it's beyond those four or five technologies. Under the umbrella of digital, there are quite a few technologies which are very relevant. And within TCS, we're calling it quote unquote digital reimagination. So we see that when we go to the CXOs and the customers, we see that digital reimagination of the enterprise is it's a pretty key, consistent, ongoing theme that resonates very strongly with our customers, with a majority of them looking at these digital technologies to transform their business. So the question is, not whether it's going to happen or when it's going to happen. It's already happened, and customers have moved far from successful pilots to very large-scale transformation initiatives in this space. So big data and analytics. That's what our topic is today. Big data and advanced analytics. That's an integral part of this whole digital ballgame. And for today, we'll focus on particularly on big data and its impact. So just to set the context a little bit, this is the holistic picture of the evolution of technology. And so if you see, it all started with a very procedural approach with technologies, programming languages like COBOL, C, Fortran, and the predominant architecture at that time was, that's when I started my career. So it all started with that, and the predominant architecture was mainframe, mid-range sort of architecture, at best open systems. We used to call them open systems, a client-server architecture. We moved on to object orientation with C++, Smalltalk, Java, and there came the three-tier architecture. Further, we moved on to component-based approach. That's where the whole internet revolution and the distributed architecture happened. And we were using technologies like Java Enterprise Edition, ASP.NET in the Microsoft world. Somewhere down the line, it moved on to a service-oriented approach, where we called it SOA, service-oriented architecture. And pretty much at that time, there was this emergence of the rich internet applications and Web 2.0 with service-oriented architecture. And finally, we moved on to what we're calling the digitally enabled enterprise architecture. So that's from a technology perspective and the evolution of it. So if you look at the similar thing from an enterprise perspective, it all started with automating manual tasks and replacing tons of paper with digital records. So it was all about aiming to create a paperless office. And in those days, 20 years back, we used to call them digitization, which is very different from what we're calling digitalization. So it's not digitization, but digitalization, what we're trying to do today. So it moved on from paperless office to enterprise applications, the burst of ERPs, from pretty much standardizing the back office processes and all that, the business processes. We moved on to service-oriented enterprise, powered by service-oriented architecture. And then we are in the digital enterprise phase, which but it's the digital technologies. What they're doing is they're actually powering a smart enterprise. We're saying that we are in the era of Industry 4.0. Within TCS, we are calling it Business 4.0, and that's what smart enterprises are. So smart enterprises are Business 4.0 enterprises powered by the digital technologies. And of course, the whole world of artificial intelligence and continuous intelligence. So this is just a context setting. So what does the future hold? Though I'm calling them This is what is already the reality today. AI and robotics, mobility, big data and analytics are focused. Cloud, social, and along and IoT. That's also very much a reality today. And what I'm calling future technologies, I'm calling them future technologies. These technologies are also already here, and they are probably at an inflection point where they're about to take off for very large, mass-scale transformational initiatives, disrupting the way we work. Smart homes and cities, 3D printing, broader and deeper automation. We've achieved automation to quite a large extent, but I think process automation and all that. But now we're going beyond that. We're enabling, we're leveraging artificial intelligence, machine learning, deep learning to actually take automation at a different level so that we can have automated decision making and all that. Genomics, we're going to talk about that a little later. Sharing economy, where there's a whole economic system in which assets or services are shared between private individuals, either free or for a fee, by means of internet. Autonomous vehicles, they're also almost a reality today. So this is from a holistic perspective where big data fits. You know, technologies are complementing nowadays. So they are coming together, they're complementing each other, they're not working in silos anymore. And that's why I wanted to, show this holistic picture from an architectural perspective. So at the bottom, you see these, physical edge devices, which we are calling things. We can further divide it into two parts probably: industrial IoT, smart grids, smart water, smart power, e-healthcare, and so on. And on the right side, on the other side, we have consumer IoT, Internet of Things, which consists of smart cars, smart homes, smartphones, smart watches, and so on. And if you move upwards, beyond those sensors, actuators, the communication hardware which comes along with the edge devices, we have the intelligent gateway, the smart gateways for connectivity. And from all that, data is going to a data lake or a hybrid cloud or a on-prem Hadoop or something. So we have this huge, huge amount of data coming in from the sensors on one hand, coming in from social media on the other hand, and there are several other things. Sometimes we are still using, enterprise service bus or a message broker to do the integration, but that is just the beginning. I think creating a data lake or creating a data foundation, it's just the beginning, and unless you apply the application and management services there, you're not going to achieve real business benefits, because we've seen customers who've gone for huge initiatives with data lakes, and ultimately they haven't really become data lakes, but they've become data graveyards or data swamps. So they couldn't really, even after creating the data lake, they couldn't really derive derive the insights out of it, the intelligence out of it, leverage the intelligence from there. So that's where the once you've created the data lake, I think that's where advanced analytics, cognitive and artificial intelligence, those are pretty much probabilistic models. If you talk about deterministic models, probably complex event processing, CEP, and so on comes in picture. People are talking about monetizing the data through APIification and microservices. So we're talking about data exchanges, data marketplaces, and so on. And above that, we are creating contextual, what we're calling contextual industry offerings. So you have the data lake, you have enabled AI, machine learning, deep learning, advanced analytics, CEP, and all the microservice APIification, all that. And ultimately, but that still remains technology. So ultimately, it has to be verticalized industry offerings, leveraging those technologies, and we can create very specific contextualized offerings for each of the verticals, be it retail, energy and utility, healthcare, and so on. We're going to actually talk about a few real life examples, case studies which we've done. And of course, this device management, the vertical layer cutting across, that wasn't there before a few years. It's becoming very relevant nowadays. Other than that, what you see on the right, the trust, security, privacy, governance, and all that, quality of service, that becomes extremely important to ensure that this whole architecture works. So now, this is what. Now let us dig into. That was context of big data and data lakes and AI and advanced analytics from a holistic perspective. So let's dig a little deeper into our discussion today. So three things we're going to discuss. What is the definition of data today? Number two, how to make information knowledge out of that. As I said, unless you can leverage your data to create, to make information and knowledge from that data, it doesn't make sense. It becomes a data graveyard or data swamp. And how the future looks like. So data is and was always one of the most important part in the enterprise. But traditionally, it meant primarily transactional data and master data, dimensional data, factual data. And it's not very long back that RDBMSs, data warehouses, and some probably desktop data visualization packages and reports. Those were the backbones behind harnessing and harvesting data. Harnessing meaning managing data, and harvesting meaning analyzing and deriving insights out of that data. But then source of data started expanding. There was email, web browsing, software logs from different sources, and ultimately social media to give it a huge push upwards. And I think there was no looking back. So there was literally an explosion of data from a multitude of sources: social media, images, blogs, video streaming, e-commerce, all those mobile data from the mobile device apps, call details, medical records, wireless sensor network, security devices, internet documents, RFID, geospatial data. I think the list goes on. So eventually, the data sets today have become so large, so big, so complex that traditional data processing softwares, the tables and RDBMSs and the related visualization tools, they were inadequate to deal with them because because of its size and associated numbers. Big data is not so easy to capture, store, search, analyze, and visualize. But now, big data has pretty much moved into absolute mainstream. It's no longer a buzzword. IT spending on big data, I saw the IBC report, and they're saying that the IT spending on big data by 2022 would be $260 billion US dollars. So that's significant amount of money, 260 billion US dollars. And if you do a split between software sales and IT services within that pie, software sales contribute some around 20%, less than 20%, and the remaining 80+% of that $260 billion is going to come from IT services. So huge amount of money on the table we're talking about. Big data skills are rare, in high demand, primarily because in the whole big data ecosystem, it consists a bunch of technologies, many people, quite a good number of technologies. So, and also companies are moving very fast to identify the right business case. So going forward, I think rapid upgrades to include or embed functionality or the replacement of the existing big data solutions is expected. But again, I think by another 2 years or so, big data will probably again become just data, and that's going to be the new normal. And organizations who does not adapt to this new normal will be either retired or they'll suffer severe economic impact. So the bottom line is that definition of data, it has far crossed the boundaries of enterprise. So which data is big for us? Let's take some example. In just 60 seconds, in every 60 seconds, in every 1 minute, there are 600 plus video uploads on YouTube. There are 320 new accounts created on Twitter in every 60 seconds. There are 435 new accounts getting created in Gmail. There are more than 500,000 new comments and 411 new accounts getting created on Facebook, 100 new accounts on LinkedIn. So we're talking about huge numbers in just 60 seconds, just 1 minute, every minute. and that's resulting in what you see on the right: 500 terabyte of new data per day in Facebook. We are talking about 1 exabyte of data generated on internet per day, which there are 1.3 zettabytes of network traffic, internet traffic getting generated every day. And if you look at the government data or other sensor data, primarily, especially after the sensors, the whole IoT thing came in, it even took the whole data thing to a different level. We're talking about yottabytes and brontobytes, which we had not even heard of a few years back. So that's how big the data is for us. So the data has become the new oil. It's a pretty common phrase which is getting used, and the whole world has become a big ocean filled with fish called data. So the question is, should you fish or can you afford to ignore? Well, theoretically, you can possibly decide to ignore, but then you have to do quite a lot of things. Firstly, you cannot pay cash for anything. You can never use internet or go online. You can't even use a telephone. You can't fill up any online forms. You can't even watch TV or smart TV. For that matter, you can't even leave house or fall sick, because whatever you do, any of these things you do, it's going to generate data. So theoretically, you can probably ignore, but I think it's an impossibility. So the question is how to make information and knowledge out of that data. The good part is we now have the technology. If you look at the original problem a few years back, all those storage capacities of hard drives have increased massively over the years. Access speeds, or the rate at which data can be read from the drives, they have not. So going by an example, one typical drive from say 1990s, late 1990s, could store roughly around 1 GB of data and had a transfer speed of around 4.4 megabytes. So you could read all the data from a full drive in around 5 minutes. So they've crossed 20 years. So over 20 years later, 1 terabyte drives are pretty much a norm, and the transfer speed is around 100 megabytes, which is from 4.4 megabytes it has come to 100 megabytes. So it takes more than roughly around 2.5 hours to read all that data of that 1 terabyte disk, and this is a long time to read all data on a single drive. And imagine that writing is even slower. So the obvious way to reduce the time to read from multiple disks at once. So imagine if we had say 100 drives, each holding 1/100th of the data, working in parallel, we could read the data in under 2 minutes. Now with that, the first problem to solve is the hardware failure. As soon as you start using many pieces of hardware, the chances are that one will fail, and the chances are fairly high. A common way of avoiding data loss is through replication. Redundant copies of data are kept by the system so that in the event of failure, there is another copy available. So we pretty much solve that problem. The second problem is that most analysis tasks need to be able to combine data in some way, and the data read from one disk may need to be combined with the data from any of the other 99 disks. So there are technologies. It was initially MapReduce, but now people don't use MapReduce that much. They've moved on to Spark for performance reasons. So there are technologies which provides a programming model that abstracts the data. That abstracts the problem from the disk, reads and writes, and transforming it into a computation over sets of keys and values. It provides a reliable storage. It provides the technology. It provides reliable storage. It provides reliable compute and processing power. So we've got the technology there. it initially started with Hadoop. So the whole concept was that it's not going to use very expensive hardware, but it's going to use cheap, reliable, cheap commodity hardware, and it's designed to run on clusters of, it's designed to run on clusters, so that the chance of node failure under the cluster is, you can replicate, and the chances of failure are less. So the big question is, how do we derive value again? So here, let's talk about a simile. This is old Indian story of 6 blind men and an elephant, and all the 6 men, they're trying to define the elephant. There are slight variations on the tale, but essentially it's about a group of blind men touching an elephant from different places to learn what it is, and each one feels a different part, but only one part, either the side or the trunk or something like that. Then they compare notes, and to their surprise, they find that there is complete disagreement of what their impression was. So big data, I think, has a lot of similarity with the story written 1,000 years back, I think. In a similar fashion, when the question of deriving value from big data comes, a confusion is being created in describing what is big data. Is it data? Is it technology? Is it algorithms? Is it people? Is it data science? Is it the business need? I've heard people around me, bragging themselves that, oh, they've created a 250 node Hadoop cluster, and they're taking pride in it. While they're taking pride in it, the technology people, the business still continues to ask, so what have I got? How do I benefit from that 250 node Hadoop cluster? So I think the thing is, it has to have a business context. And if you look at the traditional technology stack, there was things like data integration, data warehousing, BI, business intelligence, and similarly the whole big data ecosystem that has given us a new stack. But it's even more complex and acronym rich. So there is HDFS, Yarn, HBase, and different acronyms. But the basic thing still, I think, remains the same. The data still needs to be moved from place to place. There are too many layers separating users from their data. We're talking about self-service more and more these days, and too much time and know-how is required to prepare the data. The result, we have gainfully employed technologists, frustrated business managers, and a lost opportunity to remove the barriers separating business users from insights, from getting their insights. And I think the only happy party in the whole world now is people who are providing talent, the recruiters. So they're talking about data scientists who have a PhD in computer science, possessors of mastery of statistics. They're fantastic with Python, Hadoop, Spark, JSON, Hive. So really, stuff of the legends. But I think at the end of the day, all these big data technologies, they are still framework for the programmers. I think it's time that we shift our attention to the end users, for whom low-level technologies are probably as interesting as say wirings inside office wall probably. So let's focus on the business-oriented softwares that allow people to easily access and analyze unlimited amount of data from various sources on their own, and without the overhead of the traditional stack. Only then will a business user see the full value of data. So it's still not 100% reality, but we are really talking about a world where there is going to be self-service for business users. There's going to be 100% self-service for the business users, and they can pretty much on their will, dig into the data and gain insights out of it. Use intelligence to gain insights. And also, I think it's very important to implement a big data strategy. And often, people have seen people talking about things like they should utilize the data they already have first. And this dilemma or confusion leads to not having a comprehensive strategy for leveraging data, be it big, small, fast, slow. So I think it's time to take it seriously. It's a once in a lifetime opportunity for enterprises to see data in a holistic manner. They have to identify the right core data assets. Data has to be accurate. Unless you have accurate data, you don't get the right insights also. Data has to be real time, and we often talk about a thing called ethical AI or responsible AI. So the thing is, if your data is biased, if your data is not right, if your data is not accurate, the insights you get, and often they're actionable insights. So the actionable insights you get are also biased, and you don't take the right action. So uh, I think generally talking, so I think it's about having a very well-rounded strategy to enhance, which can which we need to enhance, so that the organizations are equipped for the future. So this is pretty much what how the transformation has happened. The business was asking questions like in the past, asking questions like what happened and how did it happen. So it was always about the past through reports and dashboards. That's what was happening. And there was a time when there was real time analytics. So people were asking what is happening now and why is it happening. So that was the real time data mining. And I think now what we're doing is with the advent of AI and continuous intelligence, what is likely to happen? So predictive analytics. And what should I do about it? Predictive data mining. But again, to repeat, I think in order to do all that, what is very important is you have identified the right core data assets for your organization. You have single version of truth of your data assets. You have data which can be trusted, and you have to take a holistic approach. And why do we create that whole data foundation or data lake, whatever you call it? So that you can gain, you can leverage, you can apply advanced analytics, intelligence, and decision making, automated cognitive decision making, to get insights out of data. So these are a few examples. Executive dashboards, cognitive enterprise search, customer 360, predictive analytics. There are many more, many more. So we're soon gonna dig into a few actual cases which we have done. Essentially, this is the last typical slide. So we're talking about we started with ERPs. We started with we started with semiconductors. That was the first industrial revolution, they said, and then we moved on to ERPs, CRMs, and all that. So essentially, what we are doing is we are taking a journey towards information as a service, as and when needed, and we are transcending boundaries. We are increasing our boundaries. So we're talking about if I can split it into level 1 to level 5 for maturity for an organization. At level 2, you pretty much talk about creating a data office, creating your MDM solution, enterprise, take it to the enterprise level, your MDM and all that. But once you start going towards level 4, you start talking about a much larger ecosystem. You start talking about ecosystem intelligence, where you leverage your whole ecosystem to generate and apply intelligence to generate information, to generate insights. And ultimately, the level 5 is universal intelligence, where you use intelligence, collaborative intelligence across the universe to arrive at insights. So these are some common use cases. So that is pretty much you've come towards the end, and I'm just going to pick a few to give you a flavor of what it means in the real world. So let's speak about industrial internet. I think it was a term coined by GE. So if you talk about if you look at any industry, you imagine any industry, talk about engine failures, burst pipe, very high emissions. Whenever you hear things like that, you think that it's time to alert the service engineers for repairs, right? No, actually, it's not right. It's wrong. The best time to service industrial assets is before they fail. So get ready for sensor-fitted self-monitoring machines that can talk to each other and schedule preventive maintenance checks remotely. So that's the promise of predictive maintenance. Uh, let's take an example. Let's take the example of a gas turbine. Gas turbines are increasingly getting fitted with sensors that can record and transmit real-time data and its context to big data platforms, to cloud platforms. And knowledge management and analytics tools will use then artificial intelligence and machine learning algorithms to analyze this data and schedule the visits of field service engineers in a timely manner. So now come to the field service engineers, armed with smart wearable tools, rendering digital workspace techniques, and probably with their robot buddies, will collaborate to complete the required maintenance tasks at an optimum time before issues become disruptions, before you actually see the issues. So this prevents downtime, increases efficiency, increases profitability. GE is leading this effort with created a whole platform called Predix. They're selling it across industries, especially in the manufacturing domain. And we talk about there's a phrase called power of 1%. Power of 1%. It means that this is the study which has been done that a 1% increase in efficiency in oil and gas sector by connected machines could have annualized savings of $90 billion US. So just 1% has the potential of annualized savings of $90 billion US. Let's take another example. For example, customer churn. So imagine a situation where the customer service representative, he gets a call from a very irritated customer, and the customer says, "Oh, this darn thing I bought, it doesn't work, and I've tried and tried to get help from your service folks, but they're always late. They can't even fix the thing properly, and I've had it with you guys. I want my money back." And he's very irritated. He's very angry. So by the time this customer, very irritated customer, shows his anger, what happens is there's silence from the other end, and the customer rep, he comes very calmly, listens to this obviously unhappy customer, and pulls up a bunch of information ranging from say a few years worth of transaction data, which pretty much comes from the data warehouses, the service call information, the historical service call information from the service department databases. He gets the call history from the CRM systems, and then he also gets the information of what the customer is saying about that particular company on Twitter, Facebook, blogosphere. There may also be a the stream of say previous online chats, or say thanks to cookies, a list of where he's been and when searching your website. So all this information, this variety of information the customer rep gets by the time the customer shows his anger, and all this information is then compiled so the rep can see through a visualization tool that this is actually a good customer who's probably just having a bad day. He sees from the records, from the visualization tool, the visualization tools tell the customer rep that he hasn't been troublesome in the past. He hasn't been abusive of the company in the past, and he frequently tweets, and therefore probably has a high cloud score, which makes him a social media influencer, presumably with a lot of followers. He probably gave the company a Facebook like also, and based on the records, he spends a fair amount of money with that particular company. So this gives the rep the green light to offer this customer a refund. He was asking for a refund, but I want my money back. So now the rep has all the information. He knows it's a good customer having a bad day. So he goes for a return, or probably free return along with the refund. He also can offer, for example, a free return shipping label, and maybe additionally also a coupon of 20% on his next purchase. So the customer is happy, and even better, he's decided you're also not so bad after all. Case closed. So that's how things are getting dealt now. Let's take another example, and these are actually real life examples from projects we've done. Let's take another example, a new product development. So, recently one of us wrote about the new product development analytics used by Netflix. So, in a nutshell, the company classified the key attributes of past and current products or services, and then they modeled the relationship between those attributes and the commercial success of the offerings. So, this produced a predictive model that provides Netflix with guidance about how likely a new product or service will be successful. So Netflix is not alone in this respect. There is Procter and Gamble, who also uses predictive analytics to introduce new products faster than competition, and the company works diligently on predicting likelihood of market success for these products. So the company Procter and Gamble, they integrate several things, and they integrate virtual reality and 3D design tools to create very realistic virtual prototypes of the product. But moreover, Procter and Gamble, they use data and analytics from several sources, from focus groups, from social media, from test markets, from uh, early store rollouts, and they use all that information to plan, produce, and launch new products. So as Procter and Gamble and others have discovered, there is uh, there is more to commercial success than just a new product selection. And new product development, it's a broad process with many steps. So there is absolutely no doubt that with smarter decisions, this entire process can be dealt with much more effectively, and that's how you stay ahead of the competition. And I was reading a recent study from Deloitte, for example, and they say that 96% of the product innovations fail to return the cost of capital, and two-thirds fail within 2 years. So I think this whole predictive modeling and using data, that is very important for the success of new products. Let's take another example. I think it's a very relevant example. We do a lot of work on pharmacovigilance and the pharmacogenomics. So, genomics is the study of the complete genetic material called genome of organism, and genomics identifies and analyzes genes in relation with diseases. So, and genetic testing, on the other hand, looks only for a specific gene or a gene mutation. So the use of both genomics and genetics represents, the progress in what we're calling preventive medicine. And genomics is making headlines in both academia as well as the celebrity world. And the amount of data which gets produced by this sequencing, mapping, and analyzing genomes propels genomics into the realm of big data. So genomics produces huge volumes of data. I'll just give you an example. For example, each human genome has 20,000 to 25,000 genes comprised of 3 million base pairs. So this amounts to 100 gigabytes of data. 100 gigabytes of data is roughly equivalent to 100,000 photos. And sequencing multiple human genomes could quickly add up to hundreds of petabytes of data. Amazing amount of data. And data created by analysis of gene interactions multiplies those even further. So unless you have the right big data technologies, it's impossible. I think, a few years back, we couldn't even think of the advancement genomics is making nowadays, primarily because we have the big data technologies. Uh, One last example, trade surveillance. We've been talking about talking a lot about trade surveillance these days. Well, surveillance has different perspectives. We're just focusing on trade surveillance for the time being. So, you know, if you look at the financial market today, the financial markets today hardly resemble the ones, say, 15 years back. So, the very high speed of electronic trading and the explosion in trade volumes, the diverse range of instruments, classes, and all that pose massive challenges. So, with all this complexity, the market abuse patterns have also become prevalent. So banks are selling out, millions of dollars in fines for market abuse violations. So in response to this complex world, European regulators, thus, they've been hard at work, and and compliance teams were fighting back with big data, trying to stay out of the regulatory hot water. So rapid response to suspect trades means that compliance teams need to access and visualize trade patterns real time and from historic data, and be able to efficiently perform trade reconstruction at any point in time. And that's how we're taking care of trade surveillance. You can see, this is not listed here, but if you look at the sporting events nowadays, the big sporting events like the Wimbledon, US Open, the FIFA World Cup, you know, big data is used in a big data and advanced analytics is being used at a very big scale. One example is Google. They've got the Google Cloud Platform (GCP). So they had been using the Google Cloud Platform, GCP platform infrastructure and analytics. They use TensorFlow and analytics to predict the results of the last FIFA World Cup. And surprisingly, amazingly, they've been making pretty accurate predictions. So I think we're at a juncture, an inflection point, where we see that customers have gone beyond those what we call successful pilots. So actually, customers are into very large scale transformation initiatives in this space. And what is very important is instead of restricting ourselves to those technology jargons and all those acronyms, we actually focus on contextualized industry offerings, which leverages data, which needs to be accurate, holistic, real time, and all that. And we use predictive models, we use machine learning, we use deep learning, we use natural language processing, we use all of that to create altogether altogether a new way of transformation of enterprises. So who will drive the show? This is I've taken it from Oracle survey. So it's saying here that the chief data officer (CDO), it's going to be very important. It is very important now. So even if you look at a few years back, CDOs were primarily, they were not as important a role they are in today's world. So chief data officers, they were primarily, most of the companies didn't have a chief data officer, and companies who had a chief data officer, CDOs were primarily looking at things like data governance, data quality, maybe data compliance and regulatory requirements. But now, the role of CDOs, they've completely transformed. So I was reading up a Gartner report. They're saying that it came out just a month back. They're saying that CDOs, they've become the linchpins or fulcrums for the whole data-driven innovation, or even probably larger, the whole digital transformation. So they're looking at variety of things. They're looking at the business use cases driven by intelligence and advanced analytics, decision automation. They're looking at for example, things like customer 360. They're looking at pricing optimization. They're looking at we talked about trade surveillance, and there are many use cases which they're looking at. So the CDOs, they're talking about monetizing the data. So the role of CDOs have completely transformed, and they are fulcrums now for the whole digital transformation. So this is the last chart I have. This is I've taken this from an article by Sean Madden, and this is a appreciation note uh, by a satisfied customer of Amazon. I'll just read it out for you. Last month, I talked to Amazon customer service about my malfunctioning Kindle, and it was such a great experience. 30 seconds after putting in a service request on Amazon's website, my phone rang, and the woman on the other end, let's call her Barbara, greeted me by name and said, I understand that you have a problem with your Kindle. My problem was resolved in under 2 minutes. I got to skip the part where I carefully spell out my last name and address, and she didn't try to upsell me on anything. And nearly a decade of ordering stuff from Amazon, I never loved the company as much as I did at that moment. And so the fact is, Amazon had been collecting information for years, and that's how they've got immense amount of data. They're also very advanced in technology. The technologies like REST and all, it started with Amazon, and so they are using that whole data to build customer relationships. They are they are using a lot of advanced analytics, cognitive techniques, so that they have the right product launch, they have the right customer relationship, and they can leverage all that. So that's we come to the end, and a little Dilbert here from a big data perspective on a lighter note, so you can uh, just look at it yourself and feel free to contact me. You can mail me about any questions you have, any feedback you have. My mail ID is given here. It's georgie.samansar@tcs.com.